In the previous videos, we reviewed all the procedures preceding the flaw detection itself. Now it's high time to work with specific types of probes. Today we will look at connecting and working with single, reflection and bridge types of probes, as well as with the rotary scanner. Single coil probe. Connect the ECP to the flaw detector using a connecting cable. Select the probe parameter in the test menu, single type. Set the ECP frequency in a range specified in the registration certificate of the ECP. It also can be specified on the probe marking. At first, set the ECP drive not more than 2 volts. Press the auto adjust key to select the capacitor while the ECP is in the air. Move the ECP to the flaw-free area of a calibration block. It is required to hold the ECP perpendicularly to the calibration block surface. Press the F1 key to balance the ECP. When working with aluminum alloys, it is recommended to position the center of the complex plane in the lower right corner. Put a signal from a liftoff in the horizontal plane. For this, it is necessary to decline the ECP from the vertical axis at an angle of 15 to 45 degrees. Press the auto lift key. In case if the first attempt to put the signal from the liftoff horizontally failed, it is necessary to repeat the steps described above, or put the liftoff signal manually using the phase change parameter. The signal from a defect should appear in the first or second quadrant of the complex plane. Increasing the gain on preamplifier and amplifier, you should maximize the signal amplitude if necessary. After changing any parameter that affects absolute value of the signal, it is necessary to perform balancing by pressing F1. While testing aluminum alloys, it is recommended to use the vertical gain for the visual spread of signals from the distortion and signals from a defect. Select the required type of threshold level. Move the probe across the artificial defect of a calibration block several times and visually set up the alarm relative to the signal from the defect. After performing all these steps, the setup procedure is considered to be completed. Reflection probe. Connect the ECP to the flaw detector using a connecting cable. Select parameter probe in the test menu, reflection type. Set the ECP frequency in a range specified in the registration certificate of the ECP or on the probe marking. Set the ECP drive value according to its registration certificate. Place the ECP to the flaw-free area of a calibration block. Press the F1 key to balance the ECP. Put the signal from a defect to the first or second quadrant of the complex plane. While increasing the gain on preamplifier and amplifier, you should maximize the signal amplitude if necessary. After changing any parameter that affects the absolute value of a signal, it is necessary to perform balancing by pressing F1. Select the required type of a threshold level. Move the probe across the artificial defect at calibration block several times and visually set up the alarm level relative to the signal from the defect. Bridge probe. Connect the ECP to the flaw detector using a connecting cable. Select Parameter Probe in the test menu, Bridge Type. Set the ECP frequency in a range specified in the registration certificate of the ECP or on the probe marking. Set the ECP drive not more than recommended in its registration certificate. Place the ECP to the Flaw-free area of a calibration block. Press the F1 key to balance the ECP. It is recommended the signal from the defect to be placed vertically. To correct the ECP phase, use the phase parameter. While increasing the gain on preamplifier and amplifier, you should maximize the signal amplitude, if necessary. After changing any parameter that affects the absolute value of a signal, it is necessary to perform balancing by pressing F1. Select the required type of a threshold level. Move the probe across the artificial defect at calibration block several times and visually set up the alarm level relative to the signal from the defect. During the testing procedure, defects on the welded joints will be similar to those on the reference standard. Rotation probe. Connect the ECP to the rotary scanner. Markings on the housing of the probe and scanner should coincide. Insert the ECP in the scanner without applying excessive force. Connect the rotary scanner to the Flaw detector using a connecting cable. Set the ECP frequency and drive in a range specified in the registration certificate of the ECP. At rod present position, set up on. Now choose the type of a rotary scanner and press the Save Default key. Press the power button on the rotary scanner. Set the required rounds for the scanner. Put the ECP into the hole of the calibration block. Press the power button on the rotary scanner case. Press F1 to balance the ECP. Select the bandpass filter and perform its setting. First of all, minimize the distortion signals from ECP in the hole by setting the LB parameter, and then proceed with the HB setting. You can correct the ECP phase using the phase parameter. While increasing the gain on preamplifier and amplifier, maximize the signal amplitude if necessary. After changing any parameter that affects absolute value of the signal, it is important to perform balancing by pressing F1. During the ECP rotation in a hole, perform the alarm setup. Observing the position of the signal from the defect on the strip charts, we can conclude about the orientation of the defect in the hole relative to the position of the scanner.